Boom. Share screen. All right, I think I got it. So I said a few weeks, and I don't know if that was perfectly accurate or not, but I do think that this factoring, and you'll get a test just on factoring, by the way. So it won't be a district assessment kind of test, but it will be like a what we call a formative assessment, like a big quiz. It's pretty hard. It's got a bunch of different types of factoring on it. So that will be in a few weeks, a couple weeks. So here it is, first one of the year. Today is August 19th. And again, this should be a review from algebra. I'm going to see if I can get through the first little lesson of the year without a single mistake. Operation no boo-boos. In fact, I should have one of those things like they have at a factory that says like days since last incident over there. Yeah, I don't know. I don't know if I want to do that or not. I'm scared. So we're going super basic. Let's take something like this. You guys remember what it means to do this? Do you guys remember what this word means? It's okay. It's been a summer, and I wouldn't expect you to know that. So to factor something down is to essentially divide it into pieces that would have multiplied to make it. So one thing we learned, and this was very near the end of Algebra 1. For some of you, that's been a long time. For some of you, it's just been like 3 months. But to factor a quadratic means to build the multipliers that if you multiplied them out would make this. So hopefully the lights start to come on and you're like, oh, yeah, I remember this. What do we know has to go here and here? I know that I have to put an m here, and I know that I have to put an m here, because remember that if we multiply them together, we want to make m squared, right? Now, the next step in this process is, before we really do a lot of like numbery math, is we want to look at the sign of the number in back. And because the number in back is a plus, that's pretty significant. What does it mean? Yeah, I can see Summer did not hurt your knowledge, so good job. What we know is that the numbers that we put in these two red blanks are either both positives to make a positive when they multiply, or they're both negatives. And in this case, we can figure out which scenario it is. How? Say again? The middle one. Right. And so if I look right here where this green arrow is pointing, the fact that this is a plus means that they both have to be plus signs. And then finally, we get down to doing some actual mathematics. And we know that the numbers that go in those blanks have to multiply to make 27. And there's not a lot of options. I wanted to start us off pretty easy. So what are you thinking? 3 and 9 for sure. And it's nice that, yes, yay, they make 27. But more importantly, what happens is that these make 3m and these make 9m, which is our 12m. So that's how we factor just a simple quadratic trinomial. It's very kind of, you want another simple one like that before we transition? Give you one more easy one. How about n squared minus 4n minus 45? You want to be pretty robotic when it comes to factoring, and I'm going to try to make that pretty clear over the next couple of weeks. This isn't like a go rogue, express yourself kind of thing. It's pretty by the book. So I'm going to start by building my shells. What do I know goes in the front of each shell? For sure, n, because I'm going to multiply them to make the n squared. So that's off my list of things to worry about. What can you tell me about the signs I'm going to use? It's got to be one of each. And I don't want today and tomorrow to come and go. I don't want today to come and go, but I don't want these 2 days to come and go if you don't completely understand why that is. If the number in back is a negative, the only way in math to multiply to make a negative is either with a positive times a negative, right? Or a negative times a positive, but they cannot be both the same. We agree. So I'm just going to chuck them in there, throw in a plus and a minus. Sometimes you'll find you got to switch the order. Sometimes you got to move them backwards. That's okay. No big deal. And then we're on to figuring out what numbers multiply to make 45. What comes to mind? 9 and 5 for sure. So what happens is, and I'm going to mess up on purpose, but I want you just to kind of see how this works. So if I put a 9 and a 5, right. And so sometimes, like, even though the things feel like they're falling into place, you try it out and you realize, oh, that didn't actually work because I got 9n minus 5n, which doesn't work. Like Stesha said, that adds to make a positive. So whenever this happens, the best bet is just to take your signs, your plus and your minus, and switch them to a minus. So again, it's a pretty simple process. Really, the mission is clear. We're just trying to create multipliers that make an answer, right? Okay. There are a couple other types of quadratics that I showed you how to factor in Algebra 1. One of them is, what's unique about this? Like, it doesn't look like the other guys. What's missing? Yeah, the middle term, right? So whenever something is missing its middle term, there's a decent chance that it's one of these things. It's got a name. Anyone remember the name? Not that it matters, but it's called a difference of two squares. Some people call it dots, like if they're lazy, DOTS, but it's a difference of two squares. And difference means minus, and they're both squares. And so does anyone remember how to factor this? You do set it up the same. So I'm going to start with my shells. And correct. Good job, guys. So I set it up the same. I start by putting in my y's, because I got to get that off my to-do list. Because the 36 in the back is a negative, then I know I need one of each. And then to do the magic and make the middle term go poof, I'm going to need 1 6 and 1 -6, just like that. So that's how you factor a difference of two squares. They stick out, and you're going to really need to know what those look like as the coming weeks get much more difficult. So you got to look at it and go, I know you, difference of squares, right? And they won't all look super simple like that. So here's another example of a difference of two squares that's just more complex. Not a lot. Again, my job is to, as a good factor, my job is to identify quickly what am I up against. Like it can't be, you got to look and just, I know who you are. Like I know you look like the other ones. And so it's a difference of two squares. So I'm going to begin by setting it up the same way. And because it's a difference of squares, do you guys know why it's a difference of, do you know how I can tell? It's not just because it's short and has a minus sign. How can I actually tell that it is a difference of squares?
49 is 7 squared.
And you're right, Stephen, but there's one more little bit to it. One of them, it's not enough if one of them's a square. But you're exactly right. You just proved to me that 49 is a square. Nice. Thank you for that. And is this a square? What squared makes 9k squared? 3k. Good job. So if I can look at it, it was good teamwork. If I can look at it and say, you're a square, and that's a minus sign, then I can attack it a very certain, like repetitive sort of way. Good. So identification is key. And once we figure out these red things here, the 3k and the 7 are critical, you just put the 3k here, put another 3k here, put a 7 here, put another 7 here, make sure one of them is a plus and one of them is a minus. Simple. Have you done this before, Hugo? What's that? Okay. Any questions on that? Okay. The third type of quadratic that you will see is this. And this looks pretty standard, and quite frankly, it really is. It just comes out sort of in a cool way. You don't know it yet, but this has a name. This is called a square trinomial. It looks just like all the other quadratics to us. It's just a thing. It's just a math problem, right? So I'm going to build my shells, hop in there, get going. But there's a magic trick, and I do this a little bit in Algebra 1, and honestly, you don't even need to know this because you can get by without it, but there's a little bit of a trick to this. Do you guys notice that that's a square? What's the square root of 9m squared? 3m. Just 3m, right? And what's the square root of 16? Now, check this out. If you multiply those two white things, the 3m and the 4, what do you get? You get 12m. Now double that, what do you get? Jackpot. So the better you get at this, you start to recognize that, hey, this isn't one where I have to, the hardest ones are yet to come. This isn't a trial and error experimentation problem. This is a real simple problem if I'm willing to go and identify square, square, multiply, double. Sweet, it works. So all I have to do is put 3m here, 3m here, 4 here, 4 here. Tell me about my signs. What are they going to be? Both minuses. Good job. So the reason we call this a square trinomial is because the answer is actually that. If you don't see that, that's not the end of the world. It can save you a significant amount of time, though, if you recognize that, hey, the first term and the back term are squares. Maybe this is one of those, cheapo, simple ones. And if it's not, that's okay. But it's pretty cool. And finally, the worst of it all, these are the quadratics that pretty much keep us up at night. These are hard, difficult, like legit. The trouble with these is that they're not robotic, repetitive. I feel like everything we did in the last 10, 15 minutes is a process that you identify it and you do it the same way. You see it, you do it the same way. These just kind of suck. So does anyone remember why these suck? Because 12 is not a square, right? So I know right away that cool shortcut thing, the thing we did on the last problem, like, I'm sorry if you disagree, but eventually you'll agree that was a very simple problem, the one we just did. And eventually you'll agree with that because it was formulaic, like I could just follow the steps and do it. This one is not like that at all. Do you guys who maybe this is more fresh in your mind remember why this problem pretty much is a pooper? I mean, Keynes helped us by identifying that, okay, the square thing is out. 12 does not play nice. Let's build our shells. What has to go in the fronts? So give me an example of what it could be. Okay, so you want me to put a 3x here and a 4x here, right? But then Hugo could raise his hand and say, wait a second, hold on. Couldn't it also be a 6x and a 2x? Right? And then Kylie could raise her hand and say, well, wait a second, I'm sorry, guys, to make this worse, but couldn't it also be 12x and 1x? And the answer is yes. And so these problems, you'll remember hearing this from before, these just aren't really that enjoyable unless this is your thing. Like if math is your thing, then you might get some fun out of this, but it's a pain. And to make it even worse, what's up?
Because the 7x
That's not necessarily true. It will be true in this case, but honestly, the 3 and the 4 don't ever directly add together. This one is it's happenstance, so I don't want you to draw a conclusion that that's true. What's happening now is that there's a number in the front, so the 3 and the 4 don't just directly add together. I think you'll see what I mean. You're thinking of something like, I'm going to switch colors here just so we can get this, just to be clear. If I gave you this, what you're saying is exactly right because there is no number right here. But the number in front of the x squared, if I'd seen that question coming, I almost would have chosen a different example, but that's just coincidence in this case. Okay. The number in front of x squared, it screws the whole thing up. So where do you guys want to begin? Oh, by the way, what are my signs? A 1 plus and 1 minus? Good. And now we have to start thinking about numbers that multiply to make 12. And to make it even worse, there's a lot of those. So it could be 1, 12, 12, 1, 2, 6, 6, 2, 3, 4, 4, 3. And those are different. Order does matter. So what do you want to try? I mean, I look at it as we'll call this template A, we'll call this template B, and we'll call this template C. So you can decide. Pick a template and pick a combo. Because I really don't care. I'm not going anywhere. Template A, which combo do you want? I just need numbers that multiply to make 12. That's all. Sure. So you, like this? Let's try it out. This is how people factor. And not every problem on the worksheet is like this, but oftentimes factoring boils down to just go, try, fail, try again, fail again. I mean, it's part of the deal. And so what we have here is a combination. This is really important that you hear me say this. Really important. You do not earn anything for making 12x squared. Like, ooh, good job. And you do not earn anything for making 3 and -4 make -12. It's like, ooh, that is not what this is about. What this is about is do these white connectors multiply and then add to make this. People that think like they factored well because they did the yellow and the green, it's like, oh my God, no. That's like 5th grade work. Anyone can do that. It's making the middle that is what this is all about, right? So let's check this and see how we did. The 2 inner connectors, this one in the middle, kind of where I'm moving my pen, what do those make? 12x. And what do the 2 on the outside make? Minus 12x. And if you add those, what do you get? 0x. That is not what I wanted. So we're going to chalk that one up to a fail. Now, you have a choice at this point in time. You can stick with 3 and 4 and plug them into different templates, or you can stay within the same template and switch their order. It's up to you. You can decide what kind of factorer you are. What do you want to do? Just stay where we are, just switch them. Yeah, I don't disagree with that. So we're going to stick with 3 and 4, but we're going to put a 4 here and a 3 here. And it does change the entire dynamic of the problem for the record. You think, well, it's the same thing. It is not the same thing. What does the inside white connector now make? Nice. What does the outside white connector make? And when you add those together, jackpot. Therefore, this is the answer to this. We will spend 2 days on this. That is all. And eventually these will show up again, but they'll show up with disguises. They'll be wearing like costumes, like greatest common factor costumes. So today and tomorrow are dedicated to doing a lot of these. And then Wednesday, like I said, we move on. Good. I do not mind if during class time, if you want to work together, I do, however, want you to pay close attention to the tape on the floor. Do not put the legs of your desk on the tape. Okay, it wrecks the tape. You'll notice I set it up so the tape is an inch or two in front of the desk. I don't mean to be like Mr. Woo fancy, but please, the desks are marked. So if you move them to work with your buddy, that's fine. Just make sure they go back right where they were when you got here. Again, don't put the legs on the tape, okay? Por favor. Do you have any questions? As always, the best way to learn math is to just do math. So I'm going to hand out your first assignment of the year. We're going to try to get it done. If you don't get it done, it's okay. But by Wednesday, I'll assume that both today's and tomorrow's are done. So you take that for whatever you want. I will generally keep my recordings going. So I'm going to pause this recording, and then questions that people want to go over, I will re-record, kind of just add it on so that there are no awkward long pauses. All right, so are we on that? Which one do you want to do? We were looking. Do you want to just start with number one? Okay, so number one, we have b squared. So the 3b that's in the middle with the plus on it, he's going to wind up really not helping us right away. And the reason is because the 18 in the back is all we need. The fact that the 18 in the back is a negative means that no matter what else happens, we can say for sure that one will be a positive and one will be a negative. Do you agree with that? Okay. So the only time that this in the middle is going to come into play is when we get to the next step where we actually start trying to figure out what the answer is. We just need to make sure that they add to make plus 3b. But as far as determining what our signs are, he means nothing. It's dead to us, right? Okay. So we're going to build our shells. And we are definitively 100% going to put in one of each. Okay. And at this point now, it's a little, I say it's a guessing game, and for a while it kind of feels like that, but eventually you get good at it and it doesn't, you don't guess, like you start to just know what to do. What numbers do you want to use to multiply to make 18? 6 and 3, and that's your instincts that you have. Like you could have said 9 and 2, you could have said 18 and 1, but you didn't because you knew that 6 and 3 have that balance that when you add a positive 6 and a negative 3, or a negative 6 and a positive 3, you know they make 3. Right? So yeah, it's kind of guessy, but again, with practice, it's really not guessy. So where do you want the 6 and the 3? Perfect. And again, no gold stuff, no, stickers and pieces of candy for figuring out b times b and 6 times. Like that's easy. What matters here is you did it. You got the 6b and the minus 3b. Jackpot, done. Okay. What else would you like to go over? Oh, no. Let me pause.
Tried giving us, and it's not giving you the right.
Girls, we're going to go over number 3. They asked, and so if you want to come along for the ride, you're welcome to. Did you get 2k plus 1, 2k minus 1 on number 2? Did you do it yet? I'm sorry, I shouldn't have said that. I blurted it because I thought you were on number 3. My bad. Darn. That was dumb. All right, so we are trying to make 5m squared minus 12m and minus 32. So we know for sure that has to look like that because it's the only way 5 is a prime number, right? As well, she should have. Thank you, Stasha, for got to keep her in line. What else do we know for sure? It has to be one of each. I agree. Now, the thing about this plus and this minus is we might have to switch them later because it will matter. That's okay. That's what erasers. And so now we have to just think about numbers that multiply to make 32. What are you thinking? It's worth a shot, right? What, you want me to try them? You don't think it'll work? And I was just telling Kyla and Alicia this, that factoring is not about guessing after a while. It does become, there is a science to it. And you and your brain come together and you just start to see things like you just saw. You just had a whole conversation without me, but it was pretty dope. I liked it. And so you figured out that these make 8, right? And these make -20. And you're like, I'll be darned. There's my -12. Done. It's not about the, I mean, it's not guessing. It's so, hey, I'll just say this and I'll put this on the recording. There, you will have all the time in the world tomorrow to work, but I'm telling you that there's also more problems tomorrow. So you would be wise to probably take and get a bunch of these done before tomorrow. Otherwise, you're going to feel like, oh, piling on, man. Class will be over in 1 minute. We get out at 8:38 now.